Hello, my students, to the second episode in my series on powers. And before we start, I want to show you an important information. If we have something like -1 raised to the power of 2 and -1 raised to the power of 3 and 1 raised to the power of 2, okay, and 1 raised to the power of 3, you know 1 raised to the power of 2 is 1 multiplied by itself twice. So it's 1 times 1, which is 1. And -1 raised to the power of 2 is -1 multiplied by -1 twice here. So negative times negative is positive. So it's 1. What do you notice? We have the same result here. 1 and 1. So -1 raised to the power of 2 is the same as 1 raised to the power of 2. They are the same. And this number is negative. If you looked at the base, the first base is negative here. And the power is even power. So even power cancels the sign here, cancel the negative sign. So -1 raised to the power of 100. And instead of multiplying -1 multiplied by itself 100 times, the power is even, so the even power cancels the negative sign. So -1 raised to the power of 100 is the same as 1 raised to the power of 100. And 1 raised to the power of 100 is 1. Okay? So -1 raised to the even power is the same as 1 raised to the same even power. And if I asked you about -3 raised to the power of 100 and 3 raised to the power of 100, are they the same? Okay. Or which one of them is more than the other? It's horrendous to multiply -3 by itself 100 times. But -3 raised to the power of 100, the power here is even. So the even power cancels the negative signs. So -3 raised to the power of 100 is the same as 3 to the power of 100. They are equal. Okay. But -2, for instance, this is a negative number here, raised to the power of 5. The power here is odd. The power is odd. So -2 raised to the power of 5 equals negative. And 2 raised to the power of 5 is 32. Let's analyze it. -2 raised to the power of 5 is the same as -2 multiplied by itself 5 times. Okay. When multiplying them, negative times negative here is positive. And negative times negative here is positive. And positive times positive multiplied by negative here, which will be negative. So it's negative 32. I'm not caring about the value, but negative number. If I have negative, like -8 raised to the power of, let's say 21. The power here is odd. The power is odd. And the odd power doesn't cancel the negative. Okay, so the negative sign will remain. We'll write the negative here. It's negative, and 8 raised to the power of 21. That's it. So let's try this one here, this question here. I have -5 raised to the power of 4 multiplied by 5 raised to the power of 2 and divided by 5 raised to the power of 3. What about -5 raised to the power of 4? You know, -5 raised to the power of 4 is the same as 5 raised to the power of 4. Why is that? Because the power here is even power. And the even power cancels the negative sign. So -5 raised to the power of 4 equals 5 raised to the power of 4. Multiplied by 5 raised to the power of 2, all divided by 5 raised to the power of 3. You know, when multiplying like bases, here we have like bases, they are the same. When multiplying like bases, we write the base as it and then add powers. 4 plus 2 equals 6, divided by 5 raised to the power of 3. And when dividing like bases, we write the base as it and then subtract powers. 6 minus 3 equals 3. 5 raised to the power of 3 equals 125. Here in this example, I have different bases. We have -3, and we have -2, and we have at the bottom -3. And we have -2 at the top here, okay, and -2 at the bottom. So we have -3 at the top. This is the base at the top, and this is the base at the bottom. They are the same, -3 and -3. And you know, when dividing like bases, it's dividing because -3 is written at the top, and -3, the second -3 is written at the bottom. So we will write -3 as it. This is the base. And then subtract powers. 5 minus 3 equals 2. I subtracted powers because we are dividing. Multiplied by. We have -2 at the top here and -2 at the bottom. So they are like bases. We are going to write -2, the base, and then subtract powers. 7 minus 5 equals 2. The power minus the power. 7 minus 5 equals 2. So -3 raised to the power of 2, it's 9. -3 multiplied by -3, it's 9, times -2 multiplied by -2, it's 4. So 9 times 4 equals what? 36. Let's go to the next example. We have -1.5 raised to the power of 5 multiplied by -1 and 1/4 raised to the power of 8 divided by -3/2 raised to the power of 4 times -5/4 raised to the power of 6. So we have a mixed number here, -1.5. So we need to convert this mixed number into improper fraction. So how can we convert the mixed number into improper fraction? We'll write the denominator as it, 2, and then multiply 2 times 1, it's 2 plus 1, it's 3/2 raised to the power of 5 times. Write the negative as it. This is a mixed number. I want to write it as an improper fraction. So we'll write 4 as it, the denominator as it, then multiply 4 times 1, multiply 4 by the whole number. 4 times 1 is 4 plus 1 is 5. All raised to the power of 8 divided by -3/2 raised to the power of 4 multiplied by -5/4 raised to the power of 6. I'm not caring about the negative sign, but I'm caring about the like bases. Where are the like bases? We have -3/2. This is the base at the top, and we have also -3/2 at the bottom. They are like bases, okay? And also we have -5/4 to the power of 8. This is the base at the top, and we have the same base at the bottom. You know, when dividing like bases, we will write the base as it. We'll write -3/2. This is the base. And then subtract powers. We have 5, the power at the top and the power at the bottom. And we are dividing because one of them at the top and the other one at the bottom. So subtract 5 minus 4 equals 1. Multiplied by We have here like bases, -5/4, and we have at the bottom -5/4. So write -5/4. And then subtract powers. 8 minus 6 equals 2. And -3/2 raised to the power of 1, it's -3/2 multiplied by -5/4 raised to the power of 2. The power is even. So cancel the negative sign, cancel, because negative times negative is positive. And 5 raised to the power of 2 is 25. And 4 raised to the power of 2 is 16. Then multiply -3/2 times 25/16. So negative times positive is negative. And 3 times 25 is 75. Divided by 2 times 16, 32. Let's go to the next one. We have here in this example, we have an expression, it's negative, and 2 times A times B, all divided by 3C. And we have the power 4. The power is even. And you know, the even power cancels the negative sign. Cancels the negative sign. So it will be positive. And we don't write. We don't need to write it. Okay. And we have 2. A, B. So raise to the power of 4. So it's 2 raised to the power of 4. Distribute the power on them. A to the power of 4 and B to the power of 4. So it's 2 raised to the power of 4 and A raised to the power of 4 and B raised to the power of 4. All divided by 3 raised to the power of 4. Distribute the power on the bottom here. So 3 raised to the power of 4 and C raised to the power of 4. Okay. And simplify it, 2 raised to the power of 4, it's 16. 2 multiplied by itself 4 times 16. And A to the power of 4 as it, B to the power of 4. There are different bases. Okay, A and B, they are different bases, all divided by 3 raised to the power of 4, it's 3 multiplied by itself 4 times 3 times 3 times 3 times 3, it's 81. C to the power of 4. If you looked at this example here, we have 4x to the power of 3, y to the power of 2, all raised to the power of 7. This is the power, divided by 2x to the power of 2 and y to the power of 7. Because we are dividing, and the power is the same. We have 7 here and we have 7 here. So we can write this expression, the top and the bottom, as a one expression raised to the power of 7. Because if we have something like A to the power of 7 divided by B to the power of 7, we can write it as A over B raised to the power of 7. And I did the same here. We have the same power. We have 7 and 7. So we can divide the two expressions, this one here and this one here at the bottom, and raised both of them to the power of 7. So that is going to be 4x to the power of 3, y to the power of 2 over 2x to the power of 2, y. What about the power? 7 and 7. I put one power for each of them. I put one power for the whole expression. Then we are going to divide to simplify the expression. 4 divided by 2 equals 2. 4 divided by 2, we have 4 at the top and 2 at the bottom. So 4 divided by 2, it's 2. And we have here, we have x and x. X raised to the power of 3 and x raised to the power of 2. So write x and then subtract powers. 3 minus 2, because we are dividing, equals 1. And we have at the top y to the power of 2 and y to the power of 1, so they are like bases, and we are dividing. So write y, then subtract powers. 2 minus 1 is 1. All raised to the power of 7. So this power here is distributed on them. On 2, distribute 2, and this power is distributed in x and distributed in y. So that is going to be 2 raised to the power of 7 and x to the power of 1, and we have the power of 7. So 1 times 7 is going to be 7, and y, we have y raised to the power of 1 and raised to the power of 7. So multiply them. 1 times 7, it's 7. And 2 raised to the power of 7, it's 2 multiplied by itself 7 times. You know, 2 raised to the power of 5, 32. So 2 to the power of 6 is 64, and 2 to the power of 7 is 128. It's 2 raised to the, don't use the calculator. It's 128. X to the power of 7, y to the power of 7. That's it. Let's go to the next example. We have an expression here. It's negative. Okay. C raised to the power of 2 and all divided by d raised to the power of 1. So let's focus on the power. The power is odd. The power here is odd power. And we have a negative. This expression is negative. So we will write the negative sign as it. Why? Because the power is odd. It's negative multiplied by itself 3 times. So negative at the end. And this power here is distributed on the top and on the bottom. So it's a C. And 2, the power here is 2, and the power here is 3. So multiply them. 2 multiplied by 3 is going to be 6, divided by d here is raised to the power of 1. D is raised to the power of 1. And raised to the power of 3 also, because this power here, 3, is distributed on the top and the bottom. So it's d, and 1 times 3 equals what? 3. It will be negative c raised to the power of 6 divided by d raised to the power of 3. If we looked at this example here, we have fraction 3 over 5 raised to the power of 10. The power here is 10, multiplied by 5 over 3 to the power of 10. Because they have the same power. They have the same power, the power of 10. So we can multiply the two fractions and put or raise both of them to the power of 10. Like what? Like when I say, for instance, if we have a to the power of 7 multiplied by b to the power of 7, we can write it as ab all raised to the power of 7. So I have 3 over 5 to the power of 10 multiplied by 5 over 3 to the power of 10. Both of them, okay, raised to the power of 10. So we can write it as 3 over 5, the first fraction, multiplied by 5 over 3. And after multiplying them, raise the answer, raise the product to the power of 10. Okay? And 3 over 5 times 5 over 3 to the power of 10. So we are going to cancel 5 and 5, 3 and 3. So it's 1 to the power of 10 equals 1. That's it. The same here in this example. I have an expression raised to the power of 16 divided by expression raised to the power of 16. So we can divide the first fraction x over x to the power of 3 over y to the power of 2 divided by x to the power of 2 over y to the power of 2, all raised to the power of 16. And in division, we converted the division into multiplication. Keep the first fraction as it, keep change flip. So we are going to write x to the power of 3 over y to the power of 2 times change from times to divided and flip. X to the power of 2 divided by y to the power of 2 is going to be y to the power of 2 divided by x to the power of 2, all raised to the power of 16. Tied it up. Simplified here. We have x to the power of 2 at the top and x to the power of 2 at the bottom. So one cancel another out. You are left with x to the power of 3 at the top and x to the power of 2 at the bottom. So we are dividing. When dividing, we write the base as it. The base here is x, and they are like bases. So we are going to write x and subtract powers. 3 minus 2 equals 1. And don't forget, all raised to the power of 16. I have two powers here on x. X raised to the power of 1, raised to the power of 16. So write x and multiply powers. 1 times 16 equals what? Equals 16. Let's answer some geometric applications. Find the area of the square whose side length is 2x over 5. What is the area of the square? Area is side multiplied by itself. So area of the square equals side multiplied by itself. So side times side, or s raised to the power of 2. What is the length of the side here? The length of the side is 2x over 5. So it's 2x over 5 raised to the power of 2. 2 raised to the power of 2 equals 4. Because this power is distributed on them. This power here is distributed on them, on all terms here. So 2 raised to the power of 2 is 4, and x raised to the power of 1, because it's x, raised to the power of 2, so it's x to the power of 2, divided by 5 raised to the power of 2, it's 25. The next one, find the volume of the cube whose edge length is 3a to the power of 3 over 7. What is the volume of the cube? Volume of the cube is side multiplied by itself, multiplied by itself. The volume of the cube equals the edge length multiplied by itself 3 times. So we can write it as L. L stands for the edge length, raised to the power of 3 multiplied by itself 3 times. So we have here 3. This is the edge length, 3a to the power of 3 over 7. Multiplied by itself 3 times. And instead of multiplied by itself 3 times, we can raise it to the power of 3. You know, this power here is distributed on the top and the bottom. So it's 3 raised to the power of 3. 3, it's not 3 times 3. It's 3 raised to the power of 3. 3 multiplied by itself. How many times? 3 times. 3 times 3 times 3 equals 27. And a raised to the power of 3. All raised to the power of 3. If you have two powers, a raised to the power of 3, all raised to the power of 3. So write the base as it, a, and multiply powers. 3 times 3 equals 9. Over 7 raised to the power of 3, it's 7. raised to the power of 3. It's not 7 times 3, it's 7 multiplied by itself 3 times. 7 times 7 is 49, multiplied by 7. 7 times 9, 63. 3 carry up 6, and 7 times 4 is 28 plus 6. 7 times 4, 28 plus 6 is 34. 343. The last one here, in the opposite figure. A square is drawn inside another square. Find the area of the shaded part. How can we find the area of the shaded part? The area of the shaded part is the area of the large square minus the area of the small square. So what is the area of the large square? It's side multiplied by itself 2 times side by itself, side multiplied by itself. So 3x over 2, all raised to the power of 2, minus the area of the small square, which is x over 2 raised to the power of 2, equals 3x to the power of 2. 3 to the power of 2, it's 9. And x to the power of 2, it's x to the power of 2, over 2 raised to the power of 2, because this power is distributed on them. So it's 4, minus x over 2 raised to the power of 2. So it's x to the power of 2 over 2 to the power of 2 is 4. Okay. So I want to subtract these two fractions. So look at the denominator here. We have here 4 down here and 4 down. So write this 4. And then subtract numerators. 9x to the power of 2 minus x to the power of 2. They are like terms. So 9 minus 1 equals 8. 9 x squared minus x squared minus 1x squared. 9 minus 1 is 8. So it's 8x to the power of 2 over 4. We can simplify. 8 divided by 4 equals 2. So it's 2x to the power of 2. I simplified. Divided by 4 is 1, and divided by 4 is 2. That's it. If A equals 5 over 3, B equals negative 3 over 2, and C equals 2 over 5, find the numerical value of each of the following. A to the power of 2, C to the power of 2, all raised to the power of 2 over B. This power here is distributed on the top only. So it's 2 here. This power is on A to the power of 2. So A to the power of 2, all to the power of 2, is going to be A to the power of 4. And we have C to the power of 2, all raised to the power of 2. So write C and multiply 2 times 2 equals 4, divided by B. Pay attention again. This power is distributed on the top only. This power here is distributed on the top only. So it's B only. Don't raise it to any power. And instead of writing something like that, this line, we can write it as A to the power of 4 and C to the power of 4, okay, divided by B. And A to the power of 4, C to the power of 4. What is the value of A? Is 5 over 3 multiplied by to the power of 4. Okay, multiplied by C to the power of 4. You know, C is 2 over 5, so it's multiplied by 2 over 5 raised to the power of 4, divided by, what is the value of the B? Substitute B equals negative 3 over 2. Instead of multiplying 5 over 3 by itself 4 times, if you focused here on the powers, you will find 4 and 4 here. So We can write it as 5 over 3 times 2 over 5, all raised to the power of 4, divided by negative 3 over 2. Okay, because they are like powers. So after that, simplify. We have 5 at the top and 5 at the bottom. One cancel another out. Now you are left with 2 over 3, all raised to the power of 4, divided by negative 3 over 2. Okay. And 2 over 3 to the power of 4, it's 2 to the power of 4, which is 16 over 3 to the power of 4, 3 times 3 times 3 times 3, multiplied by itself 4 times, it's 81. Keep, change, flip. Keep, change, flip. Okay, so change from division to multiplication and flip. It will be negative. And flip it, instead of 3 over 2, write it as 2 over 3. Then simplify. If you have something to simplify, okay, simplify. We don't have any common factors between them. So multiply 16 times negative 2 is going to be negative 32 at the top, and at the bottom, 81 multiplied by 3, 3 times 1, 3, and 3 times 8 is 24. So we ended up with negative 32 over 243. If x equals 1/5 and y equals 5, find the value of x to the power of 15, y to the power of 14. X to the power of 15, you know what is x? X is 1 over 5, x to the power of 15. Y to the power of 14. So x to the power of 15, it's 1 over 5 to the power of 15. Multiplied by. We have here y to the power of 14. So it's 5 to the power of 14. 1 over 5 to the power of 15 equals 1 to the power of 15, distribute the power on the top and the bottom, over 5 to the power of 15 times 5 to the power of 14. Okay. So 1 to the power of 15 equals 1. And 1 times 5 to the power of 15, it's 5 to the power of 15. Write it as it over 5 to the power of 15. 1 is the multiplicative identity. So 1 times 5 to the power of 15, it's 5 to the power of 14 over, okay, 5 to the power of 15. When dividing like bases, write the base as it, then subtract powers. 14 minus 15 equals minus 1. And 5 raised to the power of negative 1 equals 1 over 5, as you know. Before answering the next question, I want to show you this step here. If I have 5 to the power of x multiplied by 5 to the power of 1, they are like bases. We have 5 as a base and 5 as a base. When multiplying like bases, we add powers. So it's 5, then add the powers. 5 plus, we have here, the first power is x and the second power is 1. So add powers, it will be x plus 1. So it's 5 raised to the power of x plus 1. If we have something like 5 to the power of x plus 1, you know 5 raised to the power of x plus 1? If you went back and tried to write it as 2 5s, okay? So 5 raised to the power of x plus 1, we can write this value here or this number here as 5 to the power of x multiplied by 5 to the power of 1. Okay. If you have 5, let's say, raised to the power of 2x multiplied by 5 to the power of 3. They are like bases. When multiplying like bases, we will write the base as it and add powers. It will be 2x plus 3. If you have 5 to the power of 2x plus 3, what is the origin of this? What is the origin of this expression? It's 5 raised to the power of 2x plus 3. We can write it as 5 to the power of 2x, pay attention, multiplied by 5 to the power of 3. Okay. So in this example here, I want to prove that 5 raised to the power of x plus 2 minus 5 raised to the power of x plus 1 equals 20 multiplied by 5 to the power of x. So write the first one as 5 to the power of x here. It's 5 to the power of x plus 2. So we can write it as 5 to the power of x multiplied by 5 to the power of 2 minus. We have 5 raised to the power of x plus 1. We can write 5 to the power of x plus 1 as 5 to the power of x multiplied by 5 to the power of 1. We can factorize it by taking the highest common factor, if you remember. What is the highest common factor? We have two terms here. This is the first term and this is the second term. Okay. What is the highest common factor? We have here 5 to the power of x and we have here 5 to the power of x. So we can take it as a factor, write 5 to the power of x here and open brackets. You are left with 5 to the power of 2 minus 5 to the power of 1. So it's 5 to the power of x multiplied by 5 to the power of 2. It's 25 minus 5. So it's 5 to the power of x multiplied by 25 minus 5 equals 20. And 5 to the power of x times 20, we can write it as 20 multiplied by 5 to the power of x. That's what I want to reach. I want to prove that 3 to the power of 15 plus 3 to the power of 14 is divisible by 4. Okay, 3 to the power of 15. We can write 3 to the power of 15 as 3 to the power of 15. Okay, 3 to the power of 14 multiplied by 3. You know why? Because 3 to the power of 14 multiplied by 3 to the power of 1. When multiplying like bases, we write the base as it and then add powers. 14 plus 1 is 15. And also 3 to the power of 14. You know, we can write it as 3 to the power of 14 multiplied by 1. Like 8 is the same as 8 multiplied by 1. Because 1 is the multiplicative identity. So we have 3 to the power of 15 plus 3 to the power of 14 without using the calculator. I want to prove the value here is divisible by 4. And the number is divisible by 4 if the number is a multiple of 4. Okay. So we can write 3 to the power of 15 here because it's a hard mission to multiply 3 by itself 15 times without using a calculator. But we can write 3 to the power of 15 as 3 to the power of 14 multiplied by 3 to the power of 1. All of us know that 3 to the power of 15 is the same as 3 to the power of 14 multiplied by 3 to the power of 1 plus 3 to the power of 14, we can write it as 3 raised to the power of 14 multiplied by 1. Okay, now take a factor. What is the factor here? How many times? We have 2 times here. What is the factor? The factor is 3 to the power of 14. So take 3 to the power of 14 as a factor. Then open brackets. You are left with 3 to the power of 1. Okay, plus here we have 1. So it's 3 to the power of 14 multiplied by 3 plus 1 equals what? 4. So we ended up with a value which is 4 multiplied by 3 to the power of 14. You know this value is divisible by 4. Why is that? Because we have 4 here in this value. And what is the value of 3 to the power of 14? I'm not caring about 3 to the power of 14. I don't know the value of 3 to the power of 14. Leave it, because we have 4 here multiplied by 3 to the power of 14, and I don't know the value of 3 to the power of 14. So leave it as it divided by 4. This value here is divisible by 4. You know why? Because we have 4 at the top and we have 4 at the bottom. That's it. In this example, we have negative 2 over 3 all raised to the power of negative 2. We have a negative power and we have a negative number. How can we deal with the negative power? Just switch off numerator and denominator. So it's going to be negative as it, and instead of writing 2 over 3, we can write it as 3 over 2. All raised to the power of 2. What did I do? I just exchanged the places of the numerator and denominator. Okay. I replaced the numerator with the denominator and denominator with the numerator and changed the sign of the power. We have an even power here. An even power cancel the negative. So it will be 3 over 2 all raised to the power of 2, which is 9 over 4. Don't use the calculator and find the value of 10 to the power of 2 multiplied by 0.01 100ths raised to the power of 3 all divided by 10 raised to the power of negative 3. What is the problem? The problem is having different bases. 0.01. You know, 0.01 is 1 over 100. And 1 over 100, we can write it as 1 over 10 to the power of 2. And 1 over 10 to the power of 2 is going to be 10 to the power of negative 2. Why? I did write it as 10 to the power of negative 2 to make the bases the same. So we have 10 to the power of 2 multiplied by, instead of 0.01, we can write it as 10 to the power of negative 2. And don't forget, all raised to the power of 3. Okay, so instead of 0.01, I wrote it as 10 to the power of negative 2. Okay, divided by 10 to the power of negative 3 equals 10 to the power of 2 as it multiplied by 10 And we have two powers here, -2 and 3. So multiply them. -2 multiplied by 3 is going to be -6 over 10 to the power of -3 equals, when multiplying like bases, they are like bases now, okay? So we don't have any problem in multiplication. So we're going to try 10 and then add powers. 2 plus -6 equals what? Equals -4 divided by 10 to the power of -3. And also we have like bases here. We have 10 and 10. So write the base as it, write 10 as it, and subtract powers. -4 minus -3, okay, equals 10 to the power of -4. And we have negative multiplied by negative here, negative after negative, so it's a positive, +3, equals 10 to the power of -4 plus 3 equals what? -1. And 10 to the power of -1 equals 1 over 10. That's it. In this example, we have y raised to the power of 5 over y raised to the power of -2, all raised to the power of -3. Because they are like bases, y to the power of 5 divided by y to the power of -2. They are like bases. So write y as it, write y as it, and subtract powers. 5 minus -2. Write y as it, and subtract powers. 5 minus -2. And don't forget all raised to the power of -3, okay? So negative after negative, it will be positive. So it's y raised to the power of 5 plus 2, 7, okay? And all raised to the power of -3, because we have two powers. So write y and multiply 7 by -3 equals what? Equals -21. Y raised to the power of -21, we can write it as a positive power. It will be 1 over y to the power of 21. Here we have a to the power of -1 over b to the power of 2, okay? Multiplied by a to the power of -1 over 2b to the power of 2, all raised to the power of -2. They are multiplying, okay? So write the first fraction as it. It's a to the power of -1. Don't care about the negative power, okay? Over b to the power of 2 as it, multiplied by here. We have a, and this a is raised to two powers, -1 and -2. So multiply them. So that is going to be a -1 multiplied by -2 equals 2 over. This power here is distributed on them. -2, this power here is distributed on them, on the top and on the bottom. So it's 2 to the power of -2 and b to the power of 2 times -2, it's -4, because we have two powers here, 2 and -2. So I multiplied the two powers here, because this power is distributed on the top and on the bottom, okay? What is the next step? We have here at the top, we have a to the power of -1 multiplied by a to the power of 2. They are like bases. They are like bases. It's a and a. So write the base as it, write a as it. And then add powers, because when multiplying like bases, we add powers. So it's -1 plus 2 equals 1 over. I have at the bottom, I have b to the power of 2, the base is b here, multiplied by b to the power of -4. They are like bases. What about 2 to the power of -2? Write 2 to the power of negative 2 as it. But when it comes to b, we have b here raised to the power of 2 multiplied by b raised to the power of negative 4. So write b and then add powers here. 2, okay, plus negative 4 equals negative 2. Because b to the power of 2 multiplied by b to the power of negative 4 equals b to the power of 2 plus negative 4, add powers, it will be negative 2. I finished it, but I won't write it. It's 2 to the power of negative 2, b to the power of negative 2. I won't write it with the positive powers here. So what is the problem? The problem is having negative power. And how can we deal with the negative power? Just change the place of the number. So instead of writing a as it, okay, and we are going to move it to the top, 2 to the power of negative 2, to change the sign of the power, to change the sign of the power. So we're going to get as 2, we are going to write it as 2 to the power of 2. What about b to the power of negative 2? B to the power of negative 2 is written at the bottom. I want to write it with the positive power, so move it up. B to the power of 2. It will be b to the power of 2. What happened again? I changed the place of 2 to the power of negative 2 from the denominator to the numerator and changed the sign of the power. And also b to the power of negative 2, I moved it up. I moved it up and I wrote it as b to the power of 2. So I ended up with what is written at the bottom. At the bottom, you are left with nothing. So it's 1. Okay. So that will be equal to 2 to the power of 2, it's 4. And write a as it and b to the power of 2. That's it. I have negative 2s to the power of 2t, all raised to the power of 3. This is the general power on the whole, on all terms of the expression. So it's negative 2 to the power of 3. And s to the power of 2, all raised to the power of 3. So multiply the two powers here. 2 times 3 equals 6. And t is raised to the power of 1, all raised to the power of 3. So it's a t to the power of 3. I distributed the power on them. And we have at the bottom, we have negative 4s t to the power of 2, all raised to the power of 2. This power is going to be distributed on all terms here. So it's negative 4 to the power of 2, and s to the power of 1 to the power of 2, it's s to the power of 2, and t to the power of 2 or raised to the power of 2, it's t to the power of 4 equals negative 2 to the power of 3 equals negative 8, s to the power of 6, t to the power of 3 over negative 4 to the power of 2, it's 16, and s to the power of 2 and t to the power of 4. Tied it up, simplified. 8 and 16 divided by 8, 1, and divided by 8, 2. Okay, so it's negative half here. It's negative half. And s, or we can write negative 1 at the top and 2 at the bottom. Okay, we have s to the power of 6. Okay, and we have at the bottom s to the power of 2, and it's dividing. So write s and subtract powers. 6 minus 2 equals 4. And we have at the top, we have t to the power of 3, and at the bottom we have t to the power of 4. Write t as it and subtract powers. 3 minus 4 equals negative 1. Okay, so I wanna just change the sign of this power. I wanna write it as a positive power. So change the place of t. Instead of writing t at the top, write t at the bottom. So it will be negative half as it's negative 1 at the top and 2 at the bottom. S to the power of 4 as because S is raised to the positive power, and t to the power of negative 1, we are going to move it down and write it down at the bottom as t to the power of 1. Okay, equals negative S to the power of 4 over, because we don't need to write 1. 1 is the multiplicative identity over 2t. This is the simplest form of this expression. We have here m, as you see, m to the power of 2 over n to the power of negative 3, all raised to the power of negative 1. This power is distributed on all components of this expression. So it's m to the power of 2 times negative 1 equals negative 2 over. We have n to the power of negative 3 and to the power of negative 1. So multiply, it will be n multiply the powers. Negative 3 multiplied by negative 1 is going to be 3. Multiplied by here. This power here also is distributed on all components of the expression. So it's 3 to the power of negative 2. And m, because m has a power which is negative 2, and we have another power which is negative 2. So multiply them. Negative 2 multiplied by negative 2 equals 4 over n to the power of negative 2 all raised to the power of negative 2. So multiply the two powers here. Okay, because this power is distributed in all components of the expression here. So it's n to the power of negative 2 times negative 2, which is 4, equals. We have at the top, we have here m, and we have here m. So write the base as then add powers. Negative 2 plus 4. This is the power here, negative 2, and this is the power here is 4. And when multiplying like bases, add powers. Negative 2 plus 4 equals 2. Okay? And 3 to the power of negative 2, write it as over. We have here like bases. We have n and we have n. So write n as then add power. 3 plus 4 equals 7. I finished it, but I have a problem here, which is having a negative power at the top, which is negative 2. So how can we make it positive? Just to change the place. And we have two places. We have numerator and denominator. So just move it down with the positive power. And m to the power of 2 as n to the power of 7 as and move 3 to the power of negative 2, move it down, it will be 3 to the power of 2 here. So we ended up with m to the power of 2 over 3 to the power of 2, it's 9, and n to the power of 7. So we ended up with m to the power of 2 over 9, n to the power of 7. Here. What is the idea here? Simplify to the simplest form. It's 2 to the power of 10 and 3 to the power of 4. The problem here in 12. So this 12 here, we can write it as 3 times 4. 12, we can write 12 as 3 times 4. And we can write this 4 as 2 to the power of 2. That's what I'm going to do here instead of 12. So I'm going to write 2 to the power of 10 as multiplied by 3 to the power of 4 over. And instead of writing 12 to the power of 5, I'm going to write it as 3 times 2 to the power of 2, all raised to the power of 5. What is happening? And instead of 12 again, I substituted 12, 3 times 2 to the power of 2. And 3 times 2 to the power of 2 equals 12. And I put here the power, which is 5. What is the next step? Write the numerator as it. And what I'm going to write in the denominator. This power is distributed on all numbers here. So it's 3 to the power of 5 multiplied by, pay attention, we have 2 to the power of 2, all raised to the power of 5. So it's 2, write the base as it and multiply powers. 2 times 5 equals 10. Then simplify. We have 2 to the power of 10 at the top and 2 to the power of 10 at the bottom. So cancel, cancel. They are the same. You ended up with 3 to the power of 4 over 3 to the power of 5. And we are dividing them. So write the base as it and subtract powers. I have 4 minus 5. So it's 3 and 4 minus 5 equals negative 1. 3 to the power of negative 1 is going to be 1 over 3. Simplify to the simplest form. I have 6 raised to the power of 2n plus 1 times 4 to the power of negative n over 2 to the power of n. And we have 3 to the power of 2n plus 1. We can write 6. Just look at the bases and ignore the powers. Look at the bases well. We have 6 here, the base, and we have 4, the base, and we have 2, and we have 3. They are not the same. I want to write them as the same bases. So 6, just look at the base on. The 6 can be written as 2 times 3. And what about 4? 4 can be written as 2 to the power of 2. Just substitute here. Instead of 6, write it as 2 multiplied by 3 instead of 6. All raised to the power of, right, the power is it. It's 2n plus 1. Okay? Multiplied by, times. I have here 4. Instead of this 4, we can write 4 as 2 to the power of 2. And don't forget this power here, which is negative n. What did I do again? Instead of 6, I wrote it as 2 times 3. And instead of 4, I wrote it as 2 to the power of 2. All divided by. Write the denominator as a 2 to the power of n multiplied by 3 to the power of 2n plus 1. Look at the numerator again. I have 2 multiplied by 3. 2 multiplied by 3. And all raised to the power of 2n plus 1. So this power is distributed on all numbers here. So it's 2 to the power of 2n plus 1 and 3 to the power of 2n plus 1. 2 to the power of 2n plus 1 multiplied by 3 to the power of 2n plus 1. Okay? Multiplied by, I have here 2, the base is 2. Raised to the power of 2, raised to the power of negative n. So it's 2 to the power of 2 multiplied by negative n, it will be negative 2n over. Write the denominator as it. I have here 2 to the power of n multiplied by 3 to the power of 2n plus 1. What do you observe? We observe that we have 3 to the power of 2n plus 1 at the top and 3 to the power of 2n plus 1 at the bottom. Okay, so when one cancel another out. Okay, and we have like bases at the top. We have 2 and we have 2. So write 2, and because we are multiplying, so we are going to add powers. So the power it's 2n. The first power is 2n plus 1 plus negative 2n. This is the power here, and this is the power here. So it's negative 2n plus negative 2n, which is negative 2n, over. We have at the bottom, we have 2 to the power of n. We have 2 to the power of n equals. Simplify. We have here 2 to the power of 2n plus 1 negative 2n. So cancel 2n and negative 2n. It will be 2 to the power of 1 over 2 to the power of n equals, because they are like bases 2 and 2, and we are dividing, so write 2 and subtract powers. We have here 1 and we have n at the bottom. So 1 minus n. This is the simplest form. This is the simplest form of this expression. 2 to the power of 1 minus n. 2 to the power of 1 minus n. Okay. I want to find the value of the result when n equals 3. So instead of n equals 3, instead of n put 3, so it will be 2 to the power of, it will be 2 to the power of 1 minus n. Instead of n, write 3. So it will be 2 to the power of 1 minus 3, which is negative 2. And 2 to the power of negative 2, it will be 1 over 2 to the power of 2, which is 1 over 4. That's it. Here I have 2 to the power of n equals 3. This is a given. And 2 to the power of what equals 3? I don't know. It's 2 to the power of n. It's a decimal number. I don't know what is the value of n. N equals what? I don't know. But I know that 2 to the power of n equals 3. Okay, this is a given. I want to get 2 to the power of n plus 1. So 2 to the power of n plus 1, if you remember, we can write it as 2 to the power of n multiplied by 2 to the power of 1. Okay, and 2 to the power of n is given as 3. Instead of 2 to the power of n here, write 3. 2 to the power of n equals 3. This is a given. So write, instead of that, write 3. Multiplied by 2 to the power of 1, which is 2, and 3 times 2 equals 6. The next. I want to get the value of 4 to the power of n. So 4 to the power of n, we can write instead of 4. We can write it as 2 to the power of 2, all raised to the power of n. Because 2 to the power of 2 is 4. Just I wrote, instead of 4, I wrote 2 to the power of 2. 2 to the power of 2 equals 4. What is the idea here? You know, if we have something like very, very important, this idea, 5 to the power of 3, all raised to the power of 2, is the same as 5 to the power of 2, all raised to the power of 3. Because we multiply the powers. So the first one, it will be 5 to the power of 3 times 2, it's 6. And the second one, it's 2 to the power, and 2 and 3, we multiply the powers. So it's 5 to the power of 6. So we will apply the same idea here. It's 2 to the power of, just exchange n and 2. Write it as 2 to the power of 2 to the power of n is the same as 2 to the power of n all to the power of 2. 2 to the power of 2 to the power of n is the same as 2 to the power of n to the power of 2. Okay? And 2 to the power of 2 equals 2 to the power of n, sorry, equals 2 to the power of n equals 3. 2 to the power of n equals 3. So instead of 2 to the power of n, write 3, and 3 to the power of 2 equals what? Equals 9. I want to get 4 to the power of negative n. You know 4 to the power of negative n? the same as 1 over 4 to the power of n. And 4 to the power of n from the previous one, 4 to the power of n here, equals what? 4 to the power of n equals 9. So it will be 1 over 9. The last one, it's 2 to the power of n minus 1. You know 2 to the power of n minus 1? We can write it as 2 to the power of n multiplied by 2 to the power of negative 1. I split it into 2 to the power of n and 2 to the power of negative 1. And 2 to the power of n is given as 3. So it will be 3. Instead of that, write 3 times 2 to the power of negative 1. And 2 to the power of negative 1, we can write it as 1 over 2. 3 times 1 over 2 equals what? Equals 3 over 2. I hope you enjoyed this session. See you in the coming episodes. Goodbye.